is the time of our experience. Now, what's wrong with this image? First of all, there's nothing wrong, obviously, as long as we carry on our daily life. It's a very good conceptual idea about time that works very well in our daily life. But it does not work, it stops working when we look a little bit more far ahead. And the more we look far ahead, the more this number of properties that I describe about time go away. So the main message somehow, the full talk I'm giving, is that time is not a single thing. It's this multi-layered concept that has all this property that I told you. It's one-dimensional, as a metric, is oriented, is the same for everybody, is measured by clock, and so on and so forth. This, which in our intuition comes as a package, is time. It's properly thought as a combination of properties that we can dismount one by one. Time, sometimes it says, is layered, or is like a mechanism, like the engine of your scooter. You can take away one piece, the carburetor, you can take away the piston, you can take away this, you can take away that, and what remains is not the scooter. What remains is nothing at all. Right? And that's what's going to happen with time. When you take away this, take away that, what remains is nothing at all, because time is a combination of these properties. So let's see one properties one by one. The first one, maybe I'll mention 3 or 4 of these, let's say 4, to dismantle this idea of time. Some of this you might know, depending on how much physics you know or how much you've heard these stories already. Some you probably haven't known. Some are very solid knowledge. Some are things we suspect. I would say the first 3 are very solid knowledge. But the implications of taking all them together are strong. So first one, clocks measure time, fine, and clocks go all together at the same speed. Well, that's wrong. Why is wrong? Because it's a fact that if I take 2 clocks, and if I take 2 good clocks, and I move them apart, I move one, or I bring one higher and keep one lower, and I wait a little bit and I move them together, if these are good enough clocks, they will indicate a different time. It's a fact, okay? It was clearly understood by Einstein 100 years ago, so in a sense we've been knowing this for 100 years, but it's recent that we actually have good clocks, not these, that we can measure this. And today with atomic clocks, with clocks that measure easily one part time with an error of 1 in 10 to the 18, 17, 18, even 19. This is very rapidly advancing the technology of clocks. So with these clocks, you can take 2 clocks at a different altitude of 40 centimeters, 50 centimeters, and measure that. So the clock up here goes faster than the clock down here. There's more time here. There's more time for thinking, for growing older, for everything. So there is more time in your head is older than your feet. Your head has, unless you have spent all your time upside down, in which case it's the other way around, okay? Why? Well, why is it? It's a funny question here. One could say why? Well, because we know from general relativity that the Earth, which is a big rock, big mass, slows down time. So mass slows down time next to it. But why? I think the right question is why not? Why is still this hard for us to digest? Because we're used to time being the same for everybody. We're used is 2 persons have the same age and they separate. One goes to America, the other goes to China, and they come back after a while. They still have the same age. Right? That's our experience. But that's not right, because they have aged differently depending on how they moved, depending if they have lived up or more down, and so on. In our experience, these differences are small and smaller than our perception of time or the precision of our watches that we carry, so we don't notice that. But if we lived a little bit in the future, when I hope there will be starships going around at fast speed and coming down, we will have to confront that. So the reason for which we think that time is the same for everybody is because we used it. We got used to it by our approximation. It's like, if you grew up in the Netherlands, which is completely flat, you think that the Earth is just all at the same level. And somebody says, there are some places of the Earth where the Earth goes down. And we say, no, how can this? Yeah, it's called mountains. Wow, right? You have never seen mountains, so you're surprised. We live in a region in which the difference of time is small, so we're not used to this. If we had a big mass, a black hole not far from here, we'll be used to the fact that when you go to a black hole, you come back, everybody else has grown older than you. Good. Which means already that this line is just wrong, because the time between here and here, two events, is not fixed. It depends whether you were higher or whether we lower, for instance. So there isn't a single time in the universe. Already there are many times. And in fact, in Einstein general relativity, you don't have a single time. You have one time per every line, per every world line. Good, that's point one. Now, point two that follow quite rapidly from that, which in fact something that Einstein realized even before general relativity, special relativity, but it has take long for becoming absorbed, because it's shocking. In my opinion, it's one of the most shocking things, and it's perhaps the most astonishing conclusion of modern physics, which is we now are here. Okay, move a little bit. What now means? What is the meaning of now? Well, I know what is the meaning of now for me. You know what is the meaning of now for you. Is it the same now? Well, obviously, yes. Because I look at you, you look at me, and I say now, you say yes now, I hear yes now, so we're in the same now, right? And then wait a little bit, and we look at, we are in a new now, so a little bit moved here, but we're together, always together in the same now. But think for a moment. When we look around, if I look at you, do I see you now? Well, not really, because lights take time to come from you to me, right? So I see you sort of a little bit in the past. Now, time takes a few nanoseconds to come from you to me. So I see you as you were a few nanoseconds ago. Well, nanoseconds are irrelevant. But if you were on Jupiter, I would see you 2 hours ago. And if you were on a star, I would see you 4 years ago, the closest star. And if you were on a different galaxy in Andromeda, I would see you millions of years ago. So I couldn't say now is when I see you. And if you look at me in the moment I see you, you are going to see me in the past, in the future for me. So between the you I see and the you that see me in the moment I see you, there's an interval between the two, which is a few nanoseconds here, but few hours in Jupiter, and millions of years if you were in a different galaxy. So if the people in a different galaxy want to know what we're doing now, they don't know, because they're looking somehow, there's all this time for. So one can say, well, all right, okay, this is because it's hard to check, but we can devise things to say what it means to be at the same time. For instance, I could say, well, I look at you, but I know you're at a certain distance. You are on Jupiter, but I know it takes half an hour take 4 hours light to come here. So 4 hours in the future from when I look at you, that's now, okay? Except that you may be moving fast, and 4 hours in the future could be in my own future, maybe 10 years in my future. So how can the now be 10 years in the future? It doesn't make any sense. So the more you play this game, the more you realize that it's a question which is ill-posed. There's no meaning of now outside the approximation in which we can disregard the time light goes back and forth. So what we mean by now is we both look at one another and we are in the same temporality within the resolution of time that we have. Which means that the notion of now makes sense on a radius, on a bubble around us, which has a length, a size, L, which is given by the speed of light time the minimal resolution of time that we can resolve, the delta t we can resolve. That's the meaning of now. There is no meaning of now outside this bubble. With our brain, without using sophisticated clocks, we resolve probably, a tenth of a second. If you're a musician, you go a bit better than that. A tenth of a second light is much bigger than the Earth. It's a big bubble around the Earth. So on the Earth, we're all in the same now. But it's just this. Proxima b, which is a closest star, has its own now. There's no sense of putting them together. You can send signals from one to the other, signal back, but in between there is no way of saying, there's no meaning of now. And in fact, people work in general relativity, theoreticians work in general relativity, study solution of Einstein equation, they know very well that there's this four-dimensional solution. There is no preferred now, no objective now that you can pick up as from physics or from anything. Why is this astonishing? Because what is it real? What does it mean to be real? Well, we are told that what is real now, right? Is the Roman Empire real? No, it was real in the past, not now. Okay, but if now is only local, is something happening on a distant galaxy real? Well, it may be in the future, maybe in the past, but if everything is real in between, it's confusing because there are things which are the past and on the future one another. So what does this mean to be real? After we have understood that the world works like that, namely that there is no now in the universe. There are philosophers who are discussing that. That's why I talk with philosophers. Philosophers who are discussing that and pulling each other ears and fighting. The very meaning of being real, of reality in the sense of what is real now, has to be rethought after what we have understood about physics. So the idea of one instant of time, it's completely destroyed. In our little bubble, we can talk about instants of time that we share, provided that we don't go too fast, we're not precise. But globally, there is this series of events in the universe with some temporal relation between a couple of them, but no common now at all, and no order in the mathematical sense. 2. 3. And this is a little bit more complicated and less well understood than the first two. Well understood the first part, less understood the second part. The past is different from the future, right? Where there is a local past and local future, it's the past is different from the future. So let's forget the other galaxies. So let's look around us. And yesterday is completely different story than tomorrow. Yesterday is fixed, we know it. Tomorrow it's open, we don't know it. Good. So I'm a physicist. I want to know where does this distinction come from in the laws of physics. And as you probably know, the laws of mechanics don't have this distinction. The laws of electromagnetism don't have this distinction. The standard model of particle physics does not have this distinction. General relativity does not have this distinction, right? So all the basic equations of physics, quantum field theory does not have this distinction. All the fundamental equations of physics lack the distinction between past and future. But for us, the past is completely different from the future. We have books written in the past, we don't have books written in the future.